Imagine a world where computers can learn just like humans. This is the exciting promise of machine learning. It's a type of artificial intelligence that allows computers to learn from data without being explicitly programmed. Think of it like teaching a dog new tricks. We don't give them a step-by-step manual. We show them what to do, reward good behavior, and correct mistakes. Machine learning works in a similar way. We feed computers massive amounts of data. The computer then analyzes this data and learns patterns and relationships. This allows it to make predictions or decisions. Just like our furry friends learn to sit or fetch, computers learn to recognize faces, translate languages, or even drive cars. This ability to learn from data is revolutionizing many fields. From healthcare to finance, machine learning is changing the way we live, work, and interact with the world around us. But how does it actually work? Let's delve deeper into the fascinating realm of machine learning. One of the most common types of machine learning is supervised learning. In this type, the computer learns from labeled data. Think of it like having a teacher guiding the learning process. The teacher provides the computer with a set of examples. Each example includes input data and the corresponding correct output. Imagine we want to teach a computer to distinguish between pictures of apples and oranges. We would show it a series of labeled images. These images would include pictures of apples labeled as apple and pictures of oranges labeled as orange. The computer would then analyze the features of each fruit. These features could include color, shape, and size. As the computer analyzes more and more examples, it starts to identify patterns and correlations. It learns that apples are typically red, round, and smaller than oranges. This learned knowledge allows the computer to predict the label of a new, unseen image. So, when we show it a picture of an apple, it can confidently classify it as an apple. This type of learning is used in a wide range of applications. From spam filtering in your email to predicting stock prices, supervised learning is a powerful tool in the world of AI. Unlike supervised learning, unsupervised learning throws the computer into the deep end without a life jacket. It deals with unlabeled data. There's no teacher, no right or wrong answers. The computer has to make sense of the data on its own, like finding constellations in the night sky. Imagine you have a basket full of different fruits, but this time, there are no labels telling you what each fruit is. Unsupervised learning algorithms excel at finding patterns and groupings in this kind of data. They might group fruits by color, size, or even the texture of their skin. One common application of unsupervised learning is clustering. This is like automatically sorting your socks after laundry. The algorithm identifies inherent similarities within the data and groups similar items together. This is incredibly useful for tasks like customer segmentation. Businesses can use clustering algorithms to identify groups of customers with similar purchasing habits and tailor their marketing strategies accordingly. Another powerful technique is dimensionality reduction. Imagine trying to understand a data set with hundreds of features. It would be overwhelming. Dimensionality reduction helps simplify this data, making it easier to visualize and analyze. Unsupervised learning is like exploring a new city without a map. It's about discovering hidden structures and relationships in data, leading to surprising and insightful discoveries. Reinforcement learning is like teaching a dog a new trick with treats and praise. This type of machine learning focuses on training an agent to make a sequence of decisions in an environment to maximize a reward. The agent learns through trial and error. It receives positive reinforcement for good actions and negative reinforcement for bad ones. Imagine teaching a computer to play a video game like Super Mario Bros. The agent is Mario. The environment is the game world. The reward is reaching the end of the level. The agent starts by making random actions. It might jump, run, or even walk backward. Through feedback from the environment, like losing a life by walking into an enemy, the agent learns which actions lead to positive outcomes, like collecting coins or reaching the flagpole, and adjusts its strategy accordingly. This type of learning is used to develop self-driving cars, create intelligent robots, and even beat human champions in complex games like Go and chess. Reinforcement learning is all about learning from experience and adapting to new situations, much like we do in our own lives. Section 5. Baking a cake with machine learning. The ML workflow. The machine learning workflow is like baking a cake. Gather ingredients. Data collection. Mix the batter data pre-processing. Choose the right pan model selection. Bake the cake model training. frost and decorate model evaluation, serve the cake deployment. And there you have it. The ML workflow is like baking a cake. Section 6. Machine learning in our world, from healthcare to entertainment. Machine learning is no longer a futuristic concept confined to science fiction movies. It's all around us, quietly powering many applications we use every day. Let's explore some real-world examples of ML in action. Healthcare. Imagine a world where diseases are diagnosed earlier and treatments are more personalized. ML is making this a reality. From analyzing medical images to predicting patient outcomes, ML is revolutionizing healthcare. Finance banks and financial institutions are using ML to detect fraudulent transactions, assess credit risks, and provide personalized financial advice. Entertainment. Ever wondered how Netflix recommends movies you might like? It's machine learning in action. Streaming services use ML algorithms to analyze your viewing history and suggest content tailored to your taste. Transportation, self-driving cars are no longer a distant dream. Thanks to ML, autonomous vehicles can navigate complex environments, avoid obstacles, and transport passengers safely. E-commerce online retailers use ML to personalize recommendations, optimize pricing, and enhance customer service through chatbots. These are just a few examples of how machine learning is transforming various industries. As ML algorithms continue to evolve, we can expect even more innovative applications in the future. Section 7. The challenges of machine learning, data dilemmas, and ethical enigmas. While machine learning offers tremendous potential, it also presents challenges that need to be addressed. One of the biggest challenges is data bias. If the data used to train the model is biased, the model's predictions will also be biased. Imagine training a facial recognition system on a dataset predominantly composed of light-skinned faces. The system might struggle to accurately recognize people with darker skin tones. Another challenge is data privacy. As ML models require massive amounts of data, ensuring the privacy and security of this data is crucial. We need to develop robust mechanisms to protect sensitive information and prevent unauthorized access. Ethical considerations are also paramount. As machines become more intelligent, we need to ensure they are used responsibly and ethically. We need to establish clear guidelines and regulations to prevent malicious use and ensure that AI benefits humanity as a whole. Addressing these challenges is crucial for the responsible development and deployment of machine learning. By tackling these issues head-on, we can harness the power of ML for good and create a future where technology empowers and uplifts society. Section 8. From humble beginnings to a bright future. A look at machine learning's journey. The journey of machine learning has been marked by periods of both rapid progress and relative stagnation. The seeds of ML were sown in the mid-20th century with the development of the first computers and algorithms capable of learning from data. Early pioneers like Alan Turing and Arthur Samuel laid the foundation for this transformative field. However, it wasn't until recent decades that ML truly began to flourish. The exponential growth in computing power, coupled with the availability of massive datasets, fueled a renaissance in machine learning research and applications. Today, ML is advancing at an unprecedented pace, driven by breakthroughs in deep learning and the development of powerful algorithms. As we look to the future, the possibilities of ML seem limitless. From personalized medicine to smart cities, ML has the potential to revolutionize countless aspects of our lives. By embracing this transformative technology responsibly and ethically, we can unlock a future where machines augment human capabilities and help us solve some of the world's most pressing challenges. Section 9. The future is now, machine learning and our ever-evolving world. Machine learning is no longer a futuristic concept. It's here, and it's changing the world as we know it. From the way we diagnose diseases to the way we shop for groceries, ML is transforming industries and reshaping our lives. As ML algorithms become more sophisticated and data availability continues to grow, we can expect even more innovative applications to emerge. Imagine a world where personalized education tailors learning to each student's unique needs, where precision agriculture optimizes crop yields while minimizing environmental impact, and where smart homes anticipate our needs and simplify our daily routines. The future of machine learning is brimming with possibilities. By embracing this transformative technology responsibly, ethically, and with a focus on human-centered design, we can unlock a future where machines augment human capabilities and help us create a more equitable, sustainable, and prosperous world for all.